All right, welcome everybody. Um, Here we are, the beginning of Unit 13 with functions, the first day. We're going to learn those two green objectives today. And actually, I believe they're in opposite order of the way we're going to learn them. We're going to do this one first, evaluate functions for a given input value, and then we will add, subtract, multiply, and divide two or more functions together. Excuse me. So here we go. Here we've got an equation, f of x plus 4. It is this line right here. Just some refreshers for you. Plus 4 is the y-intercept because it crosses the y-axis at 4. And 2 is the slope. If you made a staircase, it would constantly go up 2 over 1, up 2 over 1. So just a quick reminder of that. So that's the graph of this equation. This is pronounced f of 1 or f of 1. To say it a little quicker, it simply means evaluate the equation by plugging a 1 in place of x. So the math is pretty straightforward. It's 2 times 1 plus 4, which will get 6, which then, by the way, I don't know how this duck is doing this. I didn't make these notes. I'm just kind of oh, I can move it. Oh, sweet. It's kind of fun, a little distraction for you. This, again, means when I plug in a 1, I got an answer of 6. So that means the x value is 1 and the y value is 6. As a coordinate, it would be 1, comma 6, which is right here on the graph. We're going to constantly try to make that connection. Where do you see your answers on the graph? So 1, 6 is that point right there. Next, let's now plug in a 4. That's all it means. F of 4, that's how you say this. F of 4. You would do 2 times 4 plus 4, right? I'm putting the 4, ooh, move that duck. Putting the 4 right there. 2 times 4 plus 4. Again, pretty easy math. That is 12. So as a coordinate, when I plug in a 4, that's x, I get a y value of 12. X, comma, y. Come on, duck. Get out. Now 4 comma 12, it does land. Where is it on the graph? It does land. It's just way up here. You know, if I extended that and I thought, okay, my x value is 4, and I went beep, beep, boop, 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 way up there to the top. This coordinate would be 4, 12. To make that connection for you. 412, 412. The last one, oh, excuse me, my palm of my hand got down there. The last one is actually the easiest one in my opinion because plugging in zeros is easy. 2 times nothing plus 4, well, that's 4. So this coordinate is 0, comma 4, which is this red one right there. And of course it works. So it's kind of nice to check your math by looking for the dot on the graph, the coordinate. So that's called evaluating. This is evaluating a function for a given input value. Now we'll do it again. This is simply a quadratic equation because it has an x squared. It makes this parabola, and you could do it on Desmos. Let me plug in the 1. You simply have to plug it into both x's in the function. So it's 1 squared minus 4 times 1 plus 3. Let's see, this is 1 squared is 1. 1 minus 4 times 1 is 4 plus 3. 1 minus 4 plus 3, I believe that is 0. So, duck, when I plug in a 1, I got a 0. When x is 1, y is 0. All right, all right, all right, all right. Okay, and that coordinate is on the graph. 1 comma 0 is right there. So just to make that connection again, 1, 0 is right here. It all works. It all checks out. 4, plug in a 4 for the x's right there and right there. So it's 4 squared minus 4 times 4 plus 3. Let me maybe just speed it up in case you want a little help with the math. On Desmos, 4 squared minus 4 times 4 plus 3. Voila. That is 3. So the coordinate is 4 comma 3, which is on my graph right, ducks in the way again, right here, over 4 and up 3. And there we have it. There, it's working out. It's working out. And the last one, third one, we will evaluate it by putting a 0 in. Let's just use blue. Put a 0 there and there. Well, it's pretty nice actually, because putting in a 0, just a lot of it's going to just fall away. Um, you know, that's just 0, so that's gone. And the answer is simply going to be 3. So plugging in a 0, I get a 3. And it works. Some more Desmos tricks for you, tricks of the trade. You can put in a function and kind of check your work. You can go y equals x, that's a y, x squared minus 4x plus 3. And voila, it graphs it for you right there. And you can see, what did I do wrong? I missed the 4. There, that matches a little bit better, right? That matches. And you can actually click on these dots and you can see some of the coordinates that we did. I mean, we did this one, the 0, 3, and we did the 1, we did those 2 right there. You can also hit the gear and just add a table. And there you go. I mean, that's essentially what you're doing, right? You are plugging in numbers into the equation. So that's like if I wanted to try the 4, I'm looking right here. If I put a 4 there, Desmos will plug it in for me and tell me that the answer is 3, that the y value is 3. And it'll also put a dot there for you, right there, 4 comma 3. So, yay, Desmos. All right, so that's the first learning target. The second one is adding, subtracting, multiplying, and dividing entire functions together. So I'm given 3 functions, f of x, g of x, and h of x. And I'm going to add them, well, different ones, subtract them, or multiply them, or even divide them. So to add them, you simply go grab each one. So f of x is this one, g of x is this one, and write them down together in one long string. So there's the green one, and then plus the red one. Whoop, get away. And so just this plus sign is this plus sign, okay? Then you simply need to put together like terms. I'll highlight 3x goes with 2x, and then 5 goes with 4. Those are the like terms. X squared doesn't have any like terms to combine with. So it would be x squared, and then 3x plus 2x is 5x. This is kind of fun, but also kind of annoying. Plus 9. So that's it. That's adding the f function to the g function. Now I'm going to add the g function to the h function. So that's this one plus this one. So putting down the g function first, that's 2x plus 4. Just transcribing it down there. Then plus, again, this plus is this plus. Then I add in the h function, which is x minus 9. Combine like terms, so the 2x goes with the x, and the plus 4 goes with the minus 9. So putting the green parts together is pretty straightforward. 2x plus x is 3x. Be careful here, it's plus 4 minus 9. It's really like 4 minus 9, which is negative 5 or minus 5. You could even write it as 3x plus negative 5. That is kind of a little bridge for you to get to here. This is the more accepted way to write the answer. All right, and then we subtract, which has a little wrinkle to it. Write down the f function first, and then the minus sign, okay? Here, I'll highlight it just to maybe make it stand out again. It's minus there and minus there. Then when I write down, sorry, it's all covered up. When I write down the h function, this, I'm going to put it in a parenthesis to make sure I pay attention to this minus. I didn't do that up here. I could have, but when you're doing pluses, it doesn't really matter. If I did put my parentheses around here and around here, it's not going to change anything. It's still 3x plus 2x is 5x. It's still plus 5 plus 4. So it's fine. But here, this negative gets distributed to both of these because I'm subtracting all of this. So it's really like x squared plus 3x plus 5, and then if you distribute to both, it makes the x minus, but then it makes what's a negative and a negative? Two negatives make a positive, so it's plus 9. Then I've correctly taken care of this subtraction piece. Then I put together the like terms. X squared is my only squared term, but I've got plus 3x minus x. So plus 3 minus 1, so that's 2, plus 2. And then plus 5 plus 9 is plus 14. So again, be careful with the negative to distribute it into the second equation. Multiplying, we're going to multiply this one times this one. This one's going to take the longest. It is x squared plus 3x plus 5. I'm going to put it in a parenthesis. That's f times h, and h is x minus 9. So this is like FOIL, first, outside, inside, last, but it's bigger than that because there's 3 terms here and 2 terms here. FOIL is when there's 2 and 2. Ideally, I have to take this x squared times both of these. Then I have to take 3x times both of these. And then I have to take 5, excuse me, my throat, times both of these. So that's 6 different multiplications. I have shown a lot of kids they can do this box method. Let's see here. I'm going to make 6 sections. Here we go. I'm going to put f on top because it has 3 parts. 1, 2, 3. And we're going to put h on the side because it has 2 parts. So x squared plus 3x plus 5. And then x minus 9 down the side. Then, like I said, there's all these multiplications. To get all 6 of these, you just multiply. So this box is x times x squared, which is x cubed. Just to maybe show you, that is, if you just want to do that over here, that is that connection, that multiplication, okay? Let's go across. This box is x times 3x, so it's plus. Let me just keep it blue. It's 3x squared. This box would be 5x because it's just x times 5. Okay. Then the next one down, this is negative 9x squared. The next one, careful with your negatives, is negative 9 times positive 3x, so that's negative 27x. And the final box is minus 45. 9 times 5. Okay. So that would, again, you would get that if you did that, those two arcs, and then those two arcs. That's 6 arcs, and that's these 6 boxes. You still have to put together like terms, okay? X cubed is the only cubed term, so I'll start there. It equals x cubed. Then I have 2 squared terms. Be careful with the signs, right? So it is 3 minus 9, which is, drum roll, negative 6x squared. Continuing over, I have 5x, so I meant to highlight. It's going to be 5x with negative 27x. 5 minus 27? Yeah, no, like, whatever, I'll do this. 5 minus 27. Okay, negative 22. So minus 22x. That was the green parts. And then the last part doesn't have anything to go with. Negative 45 doesn't have any friends. So that is a loner, so to speak. So we'll make that one yellow. Okay. So that multiplying can take quite a long time. So this is my final answer right here, to be clear. This box right there. Okay. There. Okay. Then the last one is actually not a whole lot of work to do. It's just take the g function and divide it by the h function. So here's g and here's, here's g. That goes on top. And here's h. That goes on bottom. 2x plus 4 over x minus 9. So 2x plus 4 over x minus 9. You write it like a fraction, kind of like this is suggesting. And then, believe it or not, guess what? I think that cannot be simplified. I think you're done. You do not, you don't cross these off. You can't do that because there's 2 terms on the top and there's 2 terms on the bottom. So there's really no simplifying step here. You are finished, except for this last question. What can x not equal? It's referring to over here. When you're dividing by an entire function, you have to be thinking about the denominator because you do not divide by 0. Because we can't do that. Only Chuck Norris can do that. Rest his soul. Do not divide by 0. So what makes this denominator equal 0? What value of x, when you plug it in here, gives you nothing? So that would be 9. 9 minus 9 is 0. So x cannot be 9. Any other number is fine. 9 is the only number that would cause the denominator to be nothing. So there you have it. So we have added functions, subtracted them, multiplied them, and divided them in all their ways. All right, enjoy the day. Get that homework done. Later.